Hello, Precalculus student. This is for video for 3.8 part 1, inverse of polynomial and rational functions. In chapter 1, we talk about inverse functions basic, namely in order for a function to have an inverse, it needs to be a one-to-one function. The inverse function is to map the output back into the input, so they cancel each other, or a function f of x and f inverse. So this is the notation of an inverse, f to the power -1. They cancel each other. So if you start up with the inverse, if the original function, you put it into the inverse, then you go back to x. You start out with x, you go back to x. Or if you start out with x and you go to the inverse function first, your original function would send it back to x. So these are some of the properties of the inverse function. And then the range of the inverse function is actually the domain of the original function and vice versa. So in a nutshell, you can say if I have x and I put it into f, the function, I have y, but y would be the input for the inverse function. And then if you input a particular y, you can go back to the original x. Okay, and domain, if this is a domain, a range for the original function, so the inverse function will take this as a domain and put it back to the range as the domain. So the rest of the time we would find inverse of polynomial function like x cubed, x squared, those. So what is the step? Now, in order to satisfy that it has inverse, it needs to be the polynomial function needs to be one-to-one, right? So of course we know that not everyone is one-to-one, especially the one that like x squared and even roots or this x to the fourth or negative x to the fourth, these are not one-to-one. So we need to restrict the domain, restrict the original domain, so we would make it into a one-to-one so that the inverse is a function. So the first is to restrict the domain. The second is to graph the original function to determine the range, and so that you would know the domain of the inverse function. And then to find the formula, basically you replace y by f of x. This is the swap and solve, right? Switch and solve kind of process. You replace your f of x by y, and then you interchange x and y, and you solve for y for the inverse functions formula. So let's do a few examples. So we have quite a number of examples here. So find the inverse of the 2-kit function. Is x squared. Y equal to x squared. So we have to restrict domain, right? So x squared, y equal to x squared is a function. We need to restrict it from 0 to infinity only, because if we graph it, we know that the vertex is at 0, 0. So we just cut off this part and also use this part. So restrict it this way, then we can find the inverse. So first step is to restrict domain. Usually we use the one where y is positive. So there's no particular reason, but you could restrict domain on this side, negative y, or no, not negative y, negative x. But this would give us a positive x. Restrict domain, and then we would do the solving. So rewrite x equal to y squared, and then solve for y. So to solve for y, we square root on both sides. X is equal to y. Now notice that I don't do plus and minus, right? Because if I do plus and minus, that would not work. Our range shows that it is always positive, right? Y is equal to x squared. So our restricted domain guarantee that this is only positive, so we only do positive, only positive, right? So the range here is the domain is the range of this. So the range is also 0 to infinity, right? So the domain is 0 to infinity. The range is also 0 to infinity. And we can write the inverse as f of negative 1 of x is equal to square root x. What about x cubed? Oh, x cubed, we don't have to restrict it. Oh, no, not space. So if f of x is equal to x cubed, our inverse is just do it, right? Y equal to x cubed. We don't have to restrict it. So switch x and y. So x is equal to y cubed. So y would equal to cube root of x. And so the inverse is inverse of x is only just cube root of x. So for odd root, it's much easier. Okay, so like that for that one. The x squared use a lot of space. Okay, so let's do one where we would want to find inverse of x minus 4 squared plus 4. And we already restricted the domain to 4 infinity. Why? Because we know that this is a horizontal shift right of 4 and then up 3. So you already know that your x is actually, the domain is at 4 up 3, right? Like that. 4 comma 3. So you know this is right 3 from the parent function, right 4 and up 3. So you can tell that if we want to restrict it so that there is only a one-to-one function, we would actually say the domain should be from 4 to infinities, but they already told us that it's 4 infinity. So we would just do it. So y equal to x minus 4 square plus 3. So in order to solve inverse, we say y minus 4 square plus 3 and solve for y. So in order to solve for y, we need to get rid of everything that's around y. So first is to minus 3. That we go y minus 4 square. So how do I get rid of the square? We do square root x minus 3 equal to y minus 4. So after you do square root, this square root goes away, right? So the square and the square root goes away, you have a x minus 3. So, and then we do this is a minus 4. And then we do add 4 on both sides. Add 4. So we would have square root of x minus 3, but add 4 outside equal to y. And this is the inverse function. The inverse function is x minus 3 and then plus 4. And that would plus 4. And that would reverse the x minus 4 square plus 3. And this is the inverse function. The domain of this would be the range of it. So you can see that the range is from 3 to infinity. So the domain is from 3 to infinity, right? The third example is a cube. So we don't have to restrict any domain if it's a cube because we know it is one-to-one. So we quickly just say y is equal to 7 minus x cubed. Right, so instead of writing g of x, we write y. Then switch 7 minus y cubed. Solve, right? Solve. Solve for y. So we want to get rid of the 7. X minus 7 equal to negative y cubed. And then we need to divide it by negative 1, divided by negative 1, divided by negative 1. We can write it as 7 minus x, or you can just keep on writing x minus 7 divided by negative 1. Either is fine. So equal to y cubed. And how do you solve for y? Do cube root. So that would equal to cube root of 7 minus x, and that is the inverse function. The inverse function x is cube root of 7 minus x. Okay. Next one, oh, this is a square again. Find the inverse of x squared plus 4x. Now, this is not written in a square form, not written in the vertex form. So it's a little more tricky to graph. So in order to graph it, we find a vertex, right? Find hk vertex. Remember how to do it? V equal to hk. H2 is negative b over 2a, negative 4 over 2, so it's negative 2. K is f of negative 2. So that would be negative 2 squared plus negative 8, right? So that would be equal to negative 4. So we know that this is a parabola that goes with the vertex of negative 2 and negative 4. Negative 2 and negative 4. is going up, right? But the vertex is -2, -4. So how do I restrict the domain? The domain restriction would be x is greater than -2 and then infinity, right? We want this part when x is -2 or more. So let's do it. And also we want to write it in the vertex form. So f of x would actually equal to x plus 2 because minus 4 because -2 means x minus h squared. So this is actually this one. Okay, so you do completing the square or you use the vertex form. Write it as a vertex form. Why? Because vertex form is easy to solve. You just have a square term and then you can take care of it. So we're going to find inverse now. So it equal to x plus 2 square minus 4. Switch x and y. X is equal to y plus 2 square minus 4. Get rid of the 4. So x plus 4 equal to y plus 2 square. Yeah, it's not very good. And then we do square root. Okay, x plus 4 is positive equal to y plus 2. Yeah, the writing is not very good. I don't know why. So, and we want to solve for y. So the last thing is to minus 2. Oh, this is a 4. Okay, so we would have x plus 4 and then minus 2 is equal to y. Equal to y. And that is our function. F inverse of x is equal to square root of x minus 4. No, x plus 4 and then minus 2. And so that's how we do it. This is a little tricky. You have to write it in vertex form after finding HK. And it is useful because you can use it to find the domain restriction. So you see everything works. You need to know how to do graph it by finding the vertex. After you find a vertex, then you know how to restrict the domain. The second part is inverse of radical functions. So we know radical functions is it's polynomial function because to get rid of the radical, you basically square them or cube them. If you have a square root, you cube them. You square them. If you have a cube root, if you have cube root, you cube it. So you will see that radical functions, if you want the inverse, is polynomial. So we'll do the example in the next. Do we have time? Yeah, I think maybe we do. So the same switch and solve method. Okay, so f of x is square root of 6x minus 8 plus 5. Of course, the implied domain is x has to be greater than 8 over 6, right? Because the inside has to greater than equal. You already know that the domain is this by implicit. So we don't have to worry about needing to restrict domain because they're all, one-to-one already. So write y equal to square root of 6x minus 8 plus 5. Okay, so in order to get rid of this, you have to get rid of the root. So don't square it here, but get rid of the things that's outside first. Like clean up all those things outside of the radical first before you do square root. So 6x minus 8. Now you square both sides, minus y minus 5, square both sides, and you square this, it becomes just 6x minus 8 because square and square would cancel. Now, oh, well, actually, I forgot to switch. Yeah, so I'm going to switch it here. I can actually switch it anytime I want. X minus 5 square, so I switched it to equal to 6y minus 8. Now I solve for y, right? Solve for y. It is true you can actually switch to x and y anytime, so long as you have that at the end. So in order to get rid of this, I do plus 8 on both sides. So x minus 5 square plus 8 is equal to 6y. And then I divide it by 6, divided by 6. So y is equal to this x minus 5 square plus 8 divided by 6. Okay, and that would be the inverse function. So we can write it back as the inverse is x minus 5 square plus 8